Okay, now let's take a look at a few important exercise problem. Okay, let's look at the question number 3. Which slim ID is predicted by this model to be the strongest? You know, there are many ways you can solve this. You can look at the predicted strength column and then you can try to find the maximum value. That's one way. Well, another way is you can just sort the value, use the sort value method, right? The sort value method, and then you sort them like ascending is false, right? So then you can look at the predicted strength, your predicted strength column. And then ascending is a false, then it'll show the row with the highest value, right? So this is like a one way. You can take a look at you can look at the first few lists because they ask you the strongest, right? Okay, so once again, there are many different ways for the question number 3. And the question number 4, which independent variable is the single best, you know, predictor of comprehensive, the compressive strength, right? Not comprehensive, compressive strength. Okay. So for this, you need to look at basically it asks you to find independent variable, right? With what? The smallest p-value. Because the smallest p-value means is most statistically significant, right? So that's mean by single best predictor. And if two or more independent variables have the same p-value, as in this case, in this model, what that means is, let's just go back to our summary, table. Okay, this is our summary table, right? After we get rid of two independent variables. Okay, so this is our result. And as you can see, um, if you try to find the smallest p-value, right? Unfortunately, pretty much everything is 0.000, and that's too small. I mean, including this one. Oh, by the way, sorry, we should not include the constant, right? So to be precise, look at these 000, right? And this one, right? So they are all really small. So in this case, you need to find the t value with the value that is really like far away from the center. Okay. So what I'm meaning is that let's look at the exercise problem. Okay. So basically, if more than two independent variables have same p value, in this case, many p values of 0, right? Then they can be distinguished by the t statistics, right? T stat, that is the farthest from 0 in the best, is the best in the predictor, right? So in this model, something x, this is answer, has the t stat farthest from the 0, right? So t stat farthest from the 0. Okay, so look at the t value. Okay? So this is your t value. Uh, the first one is 20, 14, 7, minus 8. Minus 8 is probably somewhere here, right? Minus 8. So this one is really far away from the center, right? 2 is here, right? And 18 is probably here, and then 20 is here, right? So the which value, right? Which value is, farthest from the 0? That's something that you have to, which independent variable, right? The t statistics from, so which t value, right, is really like located you know, farthest from this 0. Right? That's the answer. Okay? Let's go back to the problem. So you need to find the name of this independent variable. Right? There's a t instead farthest from 0. Okay, question number 5. Which statistically significant independent variable is the weakest predictor? So this time we have to find the opposite case, right? We need to find like which independent variable with that has the largest p-value. Okay, that is the smaller than the alpha. I mean, hold on. Sorry, this is wrong. So it's not the small. That is larger, right? Or the greater than the alpha, right? Oh no, actually, sorry. This is smaller. Okay, so basically every alpha, right, is smaller than 0.05 because we remove those two variables whose p-values are greater than 0.05. So every p-value at this point is less than alpha, which is 5%. But among those values, right, which independent variable has the largest p-value, right? So that's the answer, right? So among these, or another way of saying that is it will also have the t-stat closest to 0. Okay, they're the same thing. Okay, so now go back to our summary table, and then now we need to look at the p-value, right? I mean, look at this p-value. I'm sorry. Look at this p-value, right? And then you need to find the p-value. I mean, among this, you need to find the greatest p-value, right? So which independent variable has greatest p-value, or the value that is close to what? T-value, t-statistic, right? This t-value that is close to 0. That's you can easily find, right? Which independent variable. Okay. So that's the problem number. What's the problem? It's problem number what? Okay, that's the problem number 5. Okay. Okay, so in my next video lecture, I'm gonna talk about question number 6, 7, 8, 9, and 10. Thank you.